week 7. Actually, once once we get into next week is halfway. Even there's only 7 weeks after spring break if I do my calculations right. But anyway, week 7, we're nearing the halfway point. This is Linux. Course topics, we asked there any questions, and key thing there, we took that test over modules, what was it, 1 through 9, and you should review any questions you have on any of those questions. Make sure you let me know. We talked briefly about memory management. I ran through control structures. There's they go over all these inside the chapter on scripting, and we got going on backup topics today. So process scheduling, we reviewed a little bit. CPU, the processor, can do these particular things. It can do math, it can do arithmetic logic unit, it can make a decision. And there's a control unit that can move things in and out of registers. So that's where all the work's done. So how do we process that? Well, the kernel needs to manage what processes run where. And I've got a little more information on that later. What we did do today, though, we looked at the at command. We typed in the date in order to get the date and time. Then we typed the at command and gave a time. We just did time. We didn't do date or whatever. We just picked a time a little further on in the class period. And then we get this command, this at command, and then I typed in a command. And you could do multiple ones. Okay, we did just one. And then I did a Control D to get me out. And then we could use ATQ, and we could look and see our command in the queue. And then at that particular time, this command was executed. And we copied a file from one directory to another. Okay? And it appeared, I don't think everybody tried it, but most of the students gave it a whirl, see if they get it to work. Now, another way to do this is with a Chrome tab. So that would look like this. Chrome tab. You can type in Chrome tab space -L, and that'll give you a listing of your Chrome tab, unless it's blank. Okay, then you can go Chrome tab -E, and it'll open up your Chrome tab in VI in order to edit it. And so then when you create it, you can indicate what minute you want something to start, what hour, what day of the month, month of the year, or day of the week. So, for example, we did a Chrome tab. I think we did something like this. We did on the 50th minute, on the 11th hour, and then we said on any day of the month, any month of the year, and any day of the week, and then we did a copy command to copy some information from one directory to another, and we gave the absolute paths. And we actually changed the name of the file during the copy. So then, to explain, this Chrome tab at 11:50 in the morning, because we checked before they left, it ran this command. It actually copied it. So without changing that, that will run every day. That makes sense? At this time. Now, if I had other jobs to execute, I could just add those in here. And this can be a command or it could be a script. Could be a script. Alright, so the students were supposed to set up a Chrome tab to run later on in the day sometime, and then they can check it, and then set up another one to run, and then they can check it again on Wednesday and make sure it's all working. What this is going to lead to then on, we should be able to take and compress some directories using tar, and then copy that information to another directory, organize that in a script, and then have that script run at a particular time. And then eventually not copy it to another directory, but all the way to another machine. And we're going to work on that on Wednesday. When we script, we have these control structures. We have sequence, one instruction after another. We have some type of iteration, so we have a loop, and this is a flow chart representation of the materials. I write that up here. I write it over here. These are flow charts representing the information. So this, you enter, if it's true, I should put a T on here, if it's true, then you're going to process these instructions and come back up and check. As long as it's true, you'll stay in the loop. If it's false, you'll leave and go execute somewhere else. Do while and do. A conditional, you enter the condition, check if it's true or false. If it's true, you're going to do these commands. Come here and continue on in your program. If it's false, you're going to do these commands and then continue on in your program. One other one we talked about is a case structure, and I'll write those up here in a minute. Case structure, it comes in and it makes a decision on an opcode, operational code. So it looks at this. If it's an A, it's going to do these instructions and then exit. If it's a B, it'll do these instructions, exit. If it's a C, it'll do these instructions, exit. And if it doesn't match any, there's always another. Now, one thing we didn't cover, there is a for loop, which is it's a looping like this, but it's a for statement, and that's a do until. This is a do while, and that one's do until. So it keeps looping until it reaches a certain category. Okay. So, if I was to write these in here, this is a sequence. This is an iteration. Okay, 4 is an iteration. This is a conditional. And this is a case structure. All right. Moving on. A couple things we did early on. You can always check and see which processes are running in Linux. You can do a PS AUX, and the processes that are running are in memory. A program is in storage, some kind of storage. And so when we bring a program into memory, we create a process. The process becomes ready to execute. And then the kernel decides if it's going to execute this user process. And then if the user process for some reason needs to be stopped, or it's doing some I/O, it then can be blocked. Then it's going to go over here and be ready to start processing again. Now that we showed you a loop where a process can be doing something over and over and over, there is a way for it to be killed or stopped. If it's in an infinite loop, the kernel can have a way to say, well, that's beyond normal, and it can just stop the process. We did talk a little more about the kernel, shell communicating with the kernel. So this would be the heart of the operating system, and then a shell interacts with the kernel, and the user interacts with the shell. Let me clear that up a little bit. Right? So the shell, this would make an operating system. This is the kernel, this is the operating system, and then all those things to go with it would create a distribution, like what type of GUI you're using and so forth to communicate. And we also talked about the lifespan of when there's going to be updates, and we discussed that a little further in class. If you have questions on that, you ought to talk to me, because some people are a little confused. So we did talk about then was memory management. And we didn't do a whole lot, but we talked about logical addresses, and then having the memory manage unit manage that and actually save it out in physical locations. Everybody understands memory, where the processes are. It's all divided up, and there's locations that need to be accessed. So there's the physical locations where things can be, and then we have logical memory that maps to that. More of that later in the week. Well, that's it.